Hi, we are the Group 5. We are here to graduate, char. We are here to perform our physics performance task. 1. I'll give you the name of the members. Meanwhile, in another universe,
Mga bobo!
Conduction is a charging by contact between a neutral body and a charging body. So always remember that only the negative charge will move while the positive charge will stay in that certain object. So negative objects causes negative charge to other objects. So it will serve as just like a domino effect, right? But only the negative charges will transfer to other objects. And conduction is the transfer of energy by direct contact. So it is also a transfer of heat energy by means of a conductor. So what is a conductor? Conductor are those instruments that will serve as a bridge or a channel to the energy to pass through an object to another. So for example of a conductor are those steering rods, metals, and metal ladles that you use at home while cooking.
Triboelectric charging, also known as charging by friction or rubbing. Charging by friction is the transfer of electrons from one uncharged object to another by rubbing the two objects together. Some electrons can move to the other object when rubbing, because when one object is rubbed against another, static electricity can be created. This is because the rubbing creates a negative charge that is carried by electrons.
Induction charging. The induction charging is a charging method that charges an object without actually touching the object to any another charged object. This method of charging involves no contact between the charged object and a neutral object, because when an object is brought close to but not touching a neutral object, the electrons in the neutral object move either away or toward the charged object. And once the charged object is moved away, the electrons in the neutral object will return to their original position.
Electromagnetic induction. Prepare a circular coil out of copper wire. Connect the two ends of this coil to the two terminals of a sensitive galvanometer with the scale having 0 at the center. This closed circuit is shown in the diagram. Note that this circuit contains no source of electricity and the galvanometer shows 0 reading initially. Take a bar magnet NS and move it swiftly towards the coil with its north pole facing the coil. You will observe a deflection in the galvanometer when the magnet is moving. The deflection indicates that current is set up in the coil. Now, move the magnet away from the coil. The galvanometer shows again a deflection, but in the opposite direction. This means current is set up in the opposite direction. If you hold the magnet with its south pole facing the coil and repeat the above steps, the deflections are again observed, but are reversed. Similarly, motion of the coil itself also produces deflections in the galvanometer when the magnet is kept stationary. Do you observe any deflection when you just hold the magnet stationary near the coil at rest? No. A relative motion of a magnet and a coil induces the current in the coil. The current produced by a relative motion of the coil or the magnet is called an induced current and is said to be set up by an induced electromotive force, EMF. The production of an induced EMF in a coil in a closed circuit by the relative motion of the magnet and its coil is called the phenomenon of electromagnetic induction.